Good day, class. Today we are discussing algorithm and flowchart. So what do we mean by algorithm? Algorithm simply means the set of steps used in solving a problem or a given task. So that is the layman definition of algorithm. But in computer studies, we try to improve the definition and add some stuff to it. So in computer study, we define algorithm as a final set of instructions that specify a sequence of operations to be carried out in order to solve a specific problem. If you have a problem or you have a task being given to you, algorithm can help you in solving this kind of tasks or problems. So let's say your mathematics teacher was in class and he or she gave you a simple equation to work on. With the help of algorithm, you can solve this kind of problems with a step-by-step rules, a step-by-step information, a step-by-step instruction that you follow, and it will bring out the answer out. Let's assume that you want to come to school in the morning. Before you come to school in the morning, you have to get up from your bed, take your bath, eat your food, and change it to your uniform before coming to school. So let's assume that you just jump in between the steps. You wake up from bed and you're just coming to school like that. The teacher will send you back to your house because you didn't put on the school uniform. So you do not follow the normal procedure, the normal steps. So this is what algorithm just try to teach us. It tells us the ways, the steps that we need to follow in achieving our goals. So now let's look at the functions of this algorithm. First, it provides a step-by-step solution to a problem. I've already discussed it. You have a task or you have a problem that you want to solve. So algorithm give you a step-by-step information to you in solving this kind of problem. It is used to prove that a problems have a solution. Yes, all problems surely have a solution. So with algorithms, you tell you how to solve this kind of problem. And I will say it is used to give a sense of direction to the steps of solving a given problem. The problem is given to you, the task is given to you. Algorithms show you the ways, the steps in solving these problems. And next, we can discuss the characteristics of this algorithm. Yeah, we have the finiteness. What do we mean by finiteness? When we want to define algorithm the other time, we said algorithm can be defined in the definition we mentioned final set. So what we mean by final set is that it's have a start, it has a begins, and once it has where it starts, surely it will have an end. So it's a step-by-step process. So the finiteness means that it specifies an exact number of steps to be taken. And also we have absence of ambiguity. What do we mean by ambiguity? Ambiguity is when something is not clear. So that's what we mean by ambiguity. But algorithms remove the ambiguity from your program's language. And also we have sequence of execution. So algorithms show the instruction are performed from top to down. I've already tell you, before of us have your start. When you have your start, then other process will follow. Then at the bottom you have your end. And also we have the effectiveness. Effectiveness, it ensures that the solution prescribes is guaranteed to give a correct answer, and that specified process is faithfully carried out. What does this mean? This means that algorithm also ensure your reliability, as in when you write to your programs are supposed to solve the specific tasks that you want to solve, the specific problems that you need solution to. So algorithm make sure that this specific your program focus on it, and it ensure that it follow the steps from top to the bottom. And also we have the input and outputs. Some people say computer is garbage in, garbage out. That means that you have to push in something before you can get your answer back. So you have to input something before you see an output. So this is how algorithm also works. Before you can have your answer, once you start, you have to tell him, okay, this stuff will be inside, then to now give you your output. And also we have independence. Algorithms is language independence. And lastly here we have scope definition. So it specifies precisely the problems or class of problems. So we've talked about a lot of stuff about these algorithms. We talk about the characteristics and we talk about the functions. So now, let's now look how these algorithms help us to solve the problems. Let's say you are in class, you are in mathematics class, and your teacher entered and gave you a question like this. So he said, if your A equals to 10 and your B equals to 16, So this is the problem, and it now tell you that you should add this, you should add A and B together and provide an answer. So as you know, representing this mathematical means that answer equal to A plus B. So this will give you your answer. So with algorithm, you can solve these problems. In solving this with algorithm, what you have to do is you start it step by step. So you start with your step 1. So now this is your step 1. So you start. Always remember the step 1 is start. So now moving to step 2, you still write your step. This is step 2. Now step 2, you now say, okay, we talked about input the other time. So what is A? What is your B? So you have to tell the algorithm that let A equal to 10 and B equal to 5. Now you tell the algorithm that this A contains 10 and this B contains 5. So now, what next? We have to process it. We have to do this. Computer, once you input stuff into computer, it processes it, then give you your output. So now, the next thing is A plus B. So now, step 3. Step 3. Now, once you work your step 3, even when you had your A and B together, there must be something that will contain the answer inside. So that's why we use Z here. And at the same time, you can use something like answer. You can use N, you can use A, you can use C, you can use D. But the only thing you can use is you cannot use something like 8A, 9B, or #A. You can't use something like this. That's the reason why when we reach basic, we talk more about this. So now, you cannot say your step 3. Okay, your Z is now equal to A plus B. This is process. So now, your step 4. Step 4. Now, you print, which is output. You print your Z. So, and your step 5, you either end or stop. You can use stop or end. So, you can use stop. So, now, this is algorithm. You see, this is a step-wise. You follow the steps. You see, we have step 1, we have step 2, we have step 3, step 4, and step 5. And as you can see, step 1, you start. Step 2, you set your A equal to 10 and your B equal to 5. So, now, and your step 3, you now find the sum, which is the major problem that you want to solve. But you solving the problem doesn't even finish there, because you have to let us see what your answer is. So now you now print your Z. So because A and B are already inside, Z have become a container now that contains A and B together. But you now have to print your Z and show your answer to them and show your answer out. So this is a set of algorithms that they give us the value of A and B. Now let us assume that my own A equals to 1000, and Ade here, Ade said his own A is equal to 5. Why Shade said our own B equal to even 1000 or anything. So now then when I ask you probably in the exam or in your test that you should write an algorithm to add 2 numbers together. I mean, even have you to write algorithm to find the sum of 3 numbers together and even find the average. So now let's perform the magic. So now I said write an algorithm that has 2 numbers together. So this kind of algorithm you have to use that, whether it's Ajay, whether it's Shola, whether it's Ibrahim, you ask the user, what are you bringing in? Is it 5? Is it 10? Is it 7? So the user has to input to your own value. So now let's start. You said you are writing an algorithm to add 2 numbers together. So the question is user, write an algorithm to add 2 numbers together. And in this situation now, you don't know the number that the user is bringing in. So now you start with our step 1. So always say our step 1 is start. Always remember your step 1 is start. So now your step 2. So now you want to collect something from user, because you don't know what the user has in mind, but you want to affect it. So you can use input. Some use a read. So you either use your input or use a read. But in our situation, we use input. So input the first value. So now you can now represent it to X. So this one we know that, okay, they're asking me for me to input my first value. Then your step 3, always write your step, is very important, because I'm going to check it when I'm marking. So input the second number. I'll try to use value. So now Y. So you already accept the 2 values, whether it is Shade, whether it is Ibrahim, anything that they are bringing, this thing will accept it and you store it as X and Y. So now the next thing is step 4. Now step 4, we have to find the sum of it. We have to add it together. So, and when you're adding it together, you have to provide another container that will be the answer. So we now can say probably maybe let's try and change it. M equal to X plus Y. So now your next step is you must print and show your answer. So print M, and your step 6 will be the stop. Then you find it. So you have to start and you have to stop. You must have everything I have begins at an end. So now you stop. This is very clear because you just start our step 2 by asking the user input the first value, input your value that you are bringing in. And step 3, we have to use that. Okay, input the second value. What's the second value? Input it. So once, then assume the user input 1 here and input 13 here. So the algorithm will save it inside, the 1 will be inside X, the 13 will be inside Y. So here now the 1 plus 13 will be inside the M. I will now show the M. So it's very straightforward. So that's what algorithm does. It's a set of steps, as you see, you follow many steps for that here. So now let's try and make things a little bit complicated. Okay, let's assume that, okay, you want to write a program that operates from 1 to 20. So if I write a program, if I write a set of algorithms that operates 1 to 20 for you, you know you should be able to write the one that can probably maybe 1 to 100 or 1 to 1000 or 1 to n times. So now, the next question is that we should write algorithm that prints 1 to 20. That's the one we are doing in the class. So you can practice 1 to 50, 1 to 100, and 1 to n times. Yeah, there's something like that. So you should get familiar with it. So now we want to print from 1 to 20. So what will be our first step? As you know, the set of steps. So we have to say step 1. What's the step 1? Step 1 is always start. So now, when you start, the next thing is step 2. What are you going to do in step 2? Okay. So what I'm going to do in step 2. Step 2, because something initialize. So initialize, you can say your X or anything, X as 0. I'm trying to perform a magic, but it's not a magic. Just have to understand it. Initialize, start, comment from 0. Start from 0. Now see my step 3. Step 3, I have initialized X as 0. Then I have to say increment. Increment X by 1. What does I mean by that? I've already started my X at 0. Now I say increment it by 1. This is plus 1. If it is plus 1, it's equal to 1. You know? Then increment this 1 again by still another 1. You now say that 1 plus 1, which is equal to 2. So you continue to have something like that. So you see you have, what do you have next? You see you have your 1 plus 2, which is equal to 3. So you continue to have something like that. So this kind of program, we call it looping. What we mean by looping is that something that continuous, it will just continue doing, just continue occur until you have to put a full stop to it. So now how can we now put a full stop to it? Because we've already started a looping. This thing will just continue, 20. So we will not print, but this thing will continue adding 1 to this 0. So now your step 4. What will now be your step 4? So your step 4, what we are going to do in step 4 is that we are going to print your X. So now, printing your X it will now show you that 1 can add comma here. When you now see your 1, it's now the 1, 2, 3, 4, 5, 6, 7. If you continuous, I said it's looping, just continue. But now to put a full stop to it, what will you do? So now, coming to step 5, what we'll do to put a full stop to this is, you now tell you that there's something I will call if statement. I'm still going to explain more which basic program. So what you are going to do is that you use if statement. So you can now say stop, or you can even use terminate when x is less than 20. So now you can say if x is less than 20, go to step 2. Then I'm still coming back. I know I'm coming back. Your step 6, you stop. It's normal. So now the only challenge we are facing here is this step 5. Yeah, step 5, and it's very straightforward. Look at it. If x is less than 20, so once x is less than 20, if x is 19, 19 is less than 20. If x is 18, 18 is less than 20. Go back to step 2. So that's why I said give your steps. We said the set of steps. Give your steps is very important. It's very 100%. It's very important. Use it. So once x is less than 22, you should go back to step 2. So let's assume that there is no step. Then where will I go back? If the program just continue until the battery runs out. So that's why the step is very important. So we now tell you to go back to step 2. So that's another major example. So now moving to our last example. Now try to go to a real life situation. We've already said algorithm. We said the set of steps in solving a problem. You want to cook beans. What do you have to do? Probably maybe you just said, okay, you put your bit of fire. No, you cannot even cook what you don't have. You have to first go to the market, buy your beans. Once you buy your beans, then put it in water, wash it, then put your water on fire. That's a set of steps. That's you are following the steps. So that's what algorithm does. So with that, I think you should be able to put this down in your notes, because I'm going to clean it. I'm moving to the last example. And I've said the last example is, it's a real life situation. Now, what we are going to do in our last example is that, okay, maybe your mom or your dad is just working and you just encounter all these people working at the bank, and now I was just like, oh, dad or mom, if you bring your money to our bank, let's assume that you save 10,000 for us for the year, we are going to return it with an ROI. ROI is return of investment. We are going to return it with something like 1,000 or 500. That means that your mother is withdrawing 11,000, she saves 10,000, so she's withdrawing 1,000. So now that's interest. So you want to write a program, you want to write algorithm that calculates the interest. So your mom was just like, oh, I met someone today, and he was like, okay, mom, don't worry, I'll help to write algorithm, and the algorithm will help us to know the amount. They assume that your mom has intention of saving it for 2 years. So algorithm will help you to know the amount that your mother is supposed to get after 2 years. And if possible, your mother can still increase it to 5 years, the money will increase. So now, easier said than done until we enter it before we know what we are going to make with that. So now we are writing an algorithm that calculates an interest. So now, algorithm interest. So before you can even, the other time I was talking about cooking beans. So you have to get your beans, and after you get your beans, you have to rinse your pot. So in solving this, you have to first understand how do you even calculate the interest. So it's very simple. There are some tools that you need in calculating this. First is that your mother needs to go to bank and deposit a certain amount of money. So that means that your mother is saving a month, right? She's saving money. Then after, you need years of it is months. Then after, you still need what? You need rate. So these 3 things are the most vital things that you need. So you need to know the amount that your mother is giving and the duration time and the rate that the bank is giving your mother. So now that the interest, you have to divide this 312 by 100. So now we want to compose it with algorithm. In solving this, we start with our step 1. And I said our step 1 is always fast. Okay, that is very important. So now, moving to our step 2. The previous example, we accept something from this and we said you can use input or read. So now, you now say, okay, mom, how much do you want to take? So that's input. You are collecting the value from your mother. So input, you are telling your mother to input the amount she is taking, the amount. Then, coming to step 3. Mom, what is the duration? Are you ready to save this 10? Are you not going to need this 10,000 for 2 years? Are you not going to need it for 5 years? So you see, input the years. Whether it's year or years. Not use a year to the year, but we don't know what the user is bringing. That's why we just add X to it. So now, 4. The rate. Input the rate that the bank is giving. So now you collect the 3 most vital stuff that we need. Now moving to 5. So see, we call something interactive. When you want a program to be interactive, you just write before working some stuff. It will help the user to know what he or she needs to input. So to make this interactive, I just say formula for an interest. It's unnecessary, but you can put it formula for interest. You can just put a double quotation, you don't need it, and you can just put a comma. Now it will now be amount multiplied by years, multiplied by rate, and everything divided by 100. So now, what will happen next? You've already do the process, you do the calculation. What next? Just for you to think your output. You solving it doesn't mean that you still need to see the answer. So you have to write your steps. It's very important, don't forget. So step 6 now, print interest. So with this, you now be able to know the amount that the bank is supposed to give back to your mom. So the next thing is step 7, which is to stop. So you start by input the amount that your mom wants to pay, then the years, and which is the duration and the rate that the bank is giving you. And our formula is interest equals to amount multiplied by years multiplied by rate, then everything is behind it, and this will show your interest. And the next thing is stop. So, and you still have to know it's possible inside a single algorithm to print 2 things. Yes, you can put 2 things. And let's assume the other time we tried to add 2 numbers. Let's not say I said you should write set of algorithms that allow users to input 3 numbers, and the algorithm should print the addition of the 3 numbers, and also it should still print the average of the 3 numbers. So you can do something like that. Okay, let's quickly look into this example. So we need algorithm to compute sum of 3 numbers, sum and average of, can be 4 numbers, can be anything, but here we are using 3 numbers. So now I have to clean this. Yeah, so I'll put it down. So now in solving this, you know how we start, you know how we run. Step 1, which is always, yeah, you get it right, start. Then your step 2. So now we have to collect, we have to accept the user input, the user value. So we don't know what the user have in mind to input. So we now said, and I've already said you can either use your read or your input. So you can use inputs to make it more interactive. Inputs the first number or the first value. So you can now call it N1. So you can now see your step 3. It is use, I will say, input the second value, which is your N2. Now, your step 4, you have input the third value, which is your N3. Now, like the other side, we accept the interest, we accept the amount, the years, and the rate. So now, we've already collect the user first value, second value, and the third value. What we have to do is find the sum of it. We have to add it together. So that will be our step 5, which I call your process. So now the sum N1 plus N2 plus N3. So here we try to add the 3 values together. Now your step 6, average N1 plus N2 plus N3 divided by 3. So now we had here we try to find the average. Now what else? We've already performed the necessary stuff that we're going to perform. The next thing is for us to showcase our answer, for us to show our answer. That's output. So now that will be your step 7. Your step 7, print. So now print, we want to print 2 things. So we have to follow print your sum. Then your step 8, you have to print your average. And after you print the 2 things, the next thing is just for you to go to step 9 and stop or end the programs. So explain more. You know how we start. From our step 1, we start. Your step 1 is already start. So moving to step 2, we have the user to input the first value, and we return the first value as N1. So the second value as N2, and the third value as N3. So we've already accept the 3 things that we need. Then here we now say sum. Sum is N1 plus N2 plus N3. These 3 things, addition of these 3 things should be put inside sum. And same thing occurring here, we add it together and we divide it by 3 for us to get the average. So average is now a container. Now we now print the sum and we print the average. So this will show all the workings, the solution to all the workings, that the process that happened here. This will show the answer. So that is the last example. So with this, you can write any algorithm. So you just have to follow it step by step. First of all, look at the question, understand the concept, and just list it bit by bit and be able to do it. So next thing, we move to flowcharts. We've already discussed algorithm, and we said it's a set of steps in solving a particular task or a problem. So flowcharts is just the diagrammatic representation of an algorithm. So it's very simple. Instead of you writing all the steps, now we are now trying to use diagrams to represent the algorithm. So that's what flowchart is. So in a more advanced definition, so we have flowchart is a pictorial representation of an algorithm in which the steps are drawn in the forms of different shapes or boxes, and the logical flow is indicated by interconnecting arrows. So that's a more advanced definition of flowcharts. So the box represents operations and the arrow represents the sequence in which the operations are implemented. So that means we have the box they represent the operation that you have performed, and the arrows, they links the operation together. So now, which shapes are we talking about? So now, I'll now draw some shapes and the function and how to use them. So now we first of all have our oval shape. So we call the shape oval. So it's not circle. So you know, this complete circle is like this, but this is oval. So we call it oval shapes. So what does it do? So it only starts and end your programs. Start or end of the flowcharts. So the other time when we are writing algorithm, you know, we say step 1 we start, but here you start with your oval shape. So the next shape
letter F here is which shape is this? This is a rectangle. Rectangle is different from a square. So this is a rectangle. So what does a rectangle does? So what a rectangle does is that it indicates the process or instruction. So this is a rectangle. What does it do? It shows, it indicates your processing. Indicates processing or instruction. That's what it does. Or instruction. And the next shape here is parallelogram. Parallelogram. So this is parallelogram. And what does it do? What it does is it represents your inputs and your outputs. So that is what a parallelogram does in flowchart. Now we have another one, which is very essential also. What is this? This is a diamond. So what does this do? Diamond. So this is diamond is used for decision making. So and next we have normal circle, perfect circle. So this is a perfect circle. You know, this one, we call this one oval, this one is a circle. So we call it, what we use for is connector. Connector. So now we still have another one, which is the flow lines. You know, this is an arrow. So we call it flow lines. So they join each process, they join them together. And we have another one. Okay, maybe I should just shift up here. We have another one here. So we call it open rectangle, because it's not closed. Open rectangle. So what does it do? So we use it for comments. We use it for comments, or you can also call it explanation. So what's the importance? The importance is that if you just write a program, you say, okay, this program adds two number, this program multiply, this program do this program does that. And I just get to your program and I was like, I don't even understand some of it. So, but with these comments, so you can put it in front of each shapes and use it to comment. Okay, this is what this program does. This is what I did here. This is what I did here. So now, and when you print out, the comments did not show. So you can write comments as long as you like. Because when your programs, when you run your programs, the comments do not show. So then the last one, I have the hexagon. So you know, hexa means 6. You know you have pentagon. So what an hexagon does, hexagon, is that it loop. You know the other time I talk about loop. So loop, I tell you that it's just a continuous stuff. So it loop, we use it to loop a program as in continuously. So that's it. We have the oval, rectangle, we have a parallelogram, diagram, diamond, circle, flow arrows, and the open rectangle, and your hexagons, which loops the program. So now, looking to the example, you've already know the definition of flowcharts, and you know it's just a diagrammatic representation of your algorithm. Instead of you writing step, we use shapes to represent it. So now, I'm going to clean this off and move to an example. So, yeah, the other side, I forgot to tell you, in computer study, the most essential, anytime that you want to start learning a program, what we use to teach our students is hello world. Take note. So now, we start with hello world. So now, we want to use a flowchart to show hello world, or to program hello world. So this is an oval shape. I tell you, it's not a circle, don't call it circle, it's an oval shape. So now, you start. Flowchart to print hello world. Hello world. Now you start. We said oval shape starts. Then the next thing is what you want to do. You want to print hello world. You want to print. So if you want to print, you go with the output. And the output shape is parallelogram. Don't forget, you have to know it often. So this is it. So you now said print hello world. Hello world. Now, the next thing is, you've already printed your hello world. What else? You end. Not complete circle, use an over. So that's it. It's already doing hello world. So now, moving forward, let's say the other time we have to find the sum of A and B. So let's say they give us our x as 15 and our y as probably maybe 7 or 7.5. So now, you now say we should find the multiplication of this number. Let's not use addition this time. So we are going to multiply the two numbers and give the sum and give the answer out. So and we should write it. They are not asking how to use algorithm, they are asking how to use flowchart. Now, what we're gonna do? So it's very easier. You start with your oval shape. Let's remember, starts. Now you start. What next? You have your x at 15 and you have your y at 7.5. So you are not asking user for anything. So you input, and you know the shape of input is parallelogram, don't forget. So your x equals to 15 and your y equals to 7.5. Yes, you've already answered the two. So now what do you want to do? You want to multiply the two together. So, and I always tell you that this input, after you input the computer process, after computer process, what else? Show you the output. So now you need the process. So what do you call the process shapes? The rectangle. I said it's very different from square, don't make the mistake. So you draw square for me, that's 0. So this is a rectangle. So what I'm going to do, I want to process it. So I will now say my z equal to x multiplied by y, because I'm multiplying. Let's say you're adding z equal to plus, or you can say no, you can even say answer equal to x multiplied by y. You can even say, the other time I told you, you can use a, you can use b, but you can not use, let's say 5a equal to no. That's wrong. But when we read basic, we are going to discuss more about it. So now your z equal to x plus y. Now, what else? You have to print your answer. So now printing this, so we now have output. Use your output again. Your output. So use your output, which is parallelogram. So now you want to print it. So you have to print your z. Print z. So, and once you print what else? You have to terminate the programs. And how do we terminate it? We end with an oval shape. End. So that's it. Easy peasy. So now we've done 2 examples so far. Print hello world, then add 2 numbers together, multiplication of 2 numbers together. Now, the other time, I think we did an example on what was it? We did an example on interest, and we did another example on, I think, adding of 3 numbers together and finding the answer. Okay, yeah. The first example we did is, yeah, we did an example on printing 1 to 20. Yeah, we did something like that. So let's try to do that in the flowchart. So we are going to represent, and we are going to draw a flowchart for printing of 1 to 20, printing of number from 1 to 20. Flowchart to print number from 1 to 20. So now, you know what to do. The first thing is you start with your oval shape. And that's your start, right? So the next thing is you have to process. You have to process. So you process. And when you want to process, I tell you, you use your rectangle, draw a square for me. So you now said, initialize, if you remember, initialize x as 0. So once you initialize your x as 0, then the next thing is increment x by 1. So you have to draw your connection line, don't forget. It's very essential you draw it. Then the next thing is we are going to print x. We are going to print x. And to print, you know, you have to use your input and output, which is parallelogram, yeah? Don't forget it. So print x. Now, we print x, but the other time we talk about something like loop that we really have to stop it. So now, to stop this, or for this to continue, because we want to loop, so we have to use a decision. The other time I draw a diamond, we have to use a decision. So we now said x is less than 20. It must contain it. So, and this arrow will come like this. So this means that if x is less than 20, so here you can just let's do something to make it more interesting. X equal to you can say x less than or equal to 20. So if this happens, this thing should come back to step 2. So it's come back to step 2. Then your next thing is just that you have to end. Okay, explaining this is your start, is the oval shape, and your rectangle, which is initialize x at 0. So explain more the other time. We start our x from 0, then we say the x should be increased by 1. Then we print just 1, 2, 3, 4, 5. We print it. But here we now put a conditional diagram, which is a decision shapes, which is diamond. So we now tell you that if x is less than or equal to 20, you should go to step 2, which is initialize x at 0. But you see something here, we said no. So this means that if x mistakenly reach 21, that means if x is greater than, then it should come to no. And when it's no, the program stop, it ends, it terminates. So that is how algorithm work. You see, it's just a flow. It keeps flowing from top to bottom. So that's it. So now moving to another example. I think the other time we still discuss something like interest. Yeah, we did something like interest. So now I'm working on that. So flowchart. So calculate interest. So the other time we said the amount is very essential, the rate and the year. We said those are very essential. So what you have to do is start. Yes. So I said we start with an oval shape. Don't forget it's not a circle. So the next thing you have to input, you have to collect something from the user. So collect something from the user. Which shape do we use? So we use the input button. If you want to print, yes, it's the same shapes. Same shape that I use for input is the same shape that I use for output. So for now, what we need it for is input. We want to collect something from the user. So now collecting something from the user, we draw a parallelogram. Don't forget, shape is parallelogram. So you already know we need 3 parallelograms because we are collecting 3 stuff. So, and you have to use the flow line. I told you it's very essential. So now, here we are collecting input, amount, then remove input, year, or the other time I say yes, because you don't know. So input, rate. Now, if you collect the 3 stuff essential that you need, then the next thing just for you to process, to do the calculation. So doing the calculation, you know the shape that we use for process is what? It's rectangle. I told you, don't draw a square for me. If you draw a square for me, that's 0. Capital letter 0. Capital letter F. So you see, this is a rectangle. So now, what the formula is that interest equal to amount multiplied by year multiplied by rate. These three things together divided by 100. But to make it more clear, because I know some people say this not clear. So to make it more clear, so we said interest equal to amount multiplied by year multiplied by rate. This thing divided by 100. So yes, a time can be long as it's like. So It's only square that cannot be like this. So now, this is our process. And the next thing is just for us to print out our interest. So now, printing out your interest, you use the same shape, which is parallelogram. Don't forget, parallelogram is for input and output, yes. So print interest. And after you print interest, what else? You are not printing anything again. The only thing that you have to do is end the program with an over end. I told you, don't ever write a program without ending it. So end it. And don't ever draw circle in there. So that's another interesting example about flow charts. So now coming to our last example. Coming to this last example, you have to be very focused on this last example, because this last example will deal with determining. We are determining whether a number is even or odd number. So you all know what even number is, and you know what odd number is. So there is a number that can be divisible, can be divided by 2 and doesn't even have anything left. So let's say probably 4 divided by 2, 6 divided by 2, 8 divided by 2. These are even numbers, and you know odd numbers. So now, to do something like that, you can see try that in algorithm, and at the same time, but now we want to use flowchart to do it, and that will be our last example. So now, you know where we start, you know where and how we start. So flowchart to determine if a number is even. Not even, I said even, or odd number. Yeah. So now, how do we start? You have to start with the oval shape. That's something that we all know. Start with the oval shape. Start. Then next, moving on. You have to collect the number from the user. They did not even give us the number. Let's say probably the question was like, determine if x, let's say the question come like x equal to 10. Now determine if x is even or odd. That's very easy. Here we can just say x equal to 10. But in a situation like this, they do not even tell us. So we have to collect it from the user. You have to accept it from the user. So that's why I say use input or use read. So always remember. And how do we collect something from the user? We have to use input. We have to use input or output sign for them to know. So now, we now tell the user what do you want to collect. So now you can collect it as anything you like, but let's use input n. So I collect my own as n. So the next thing is I've already accepted the value from the user. I said your own can be x, can be anything. So now when I now collect the value from the user, so the next thing that I have to do is now process it. Now how do we now process it? Process is kind of easy and it's kind of complicated. So that's why I say I need your 100% focus here. So you need to focus. So now the next thing is I told you is process, and process goes with rectangle, not square. So now you now said remainder equal to n, while your module is 2. The module is 2. So now I'm still going to explain, but I'll focus on what we are doing first. So now we now need a decision shapes. And you know decision shape is diamond. Yes, shine bright like diamond. So now you now said remainder equal to 0. You can add question mark. Yes, I will explain everything why we had question mark. So then you can now output answer. And we use parallelogram to output, don't forget. And here you can end. Yeah, I know. Don't worry. So your even and odd is not there, so you have to add it. You can now say here should be answer equal to odd, while here is answer equal to even. So, and this will be represented by process, which is rectangle. It's not square. I already said it's not square, it is rectangle. So what now leads to this? What leads to this is this remainder. I'm sorry. Because this will come like this. So answer equal to odd. So and this side come also like this. Answer equal to even. Now, explaining this, we start with our oval shape, then we input the n because they did not give us, so that's why we ask the user to input the value for n. Then we use the parallelogram shapes. And now we use the process. Why do we use process here? Because the user have already input the n. Yes, if you input your n, we know. Now we now said the remainder equal to n. Let's assume that if there is any remainder, the remainder should be n. While the module should be 2. So this means that let's say the user inputs probably maybe 4. So 4 divided by 2 equal to 2, right? But let's say the user inputs 2 here. So I think this is 2.5. So there is remainder here. There's remainder here. This is 2 remainder 5. So coming down here, the user have already input the n and the remainder equal to n. So the module is 2. So if remainder equal to 0, we put question mark here. Is the remainder equal to 0 or not? So if the remainder equal to 0, this will come here. Answer equal to even. But if the remainder is equal to, if the remainder remains something like probably maybe 2.5, so that's not 0. As in there is something left, there is 0.5 left. So that's why the answer will come to odd. And here, whether it comes here or it comes here, the result will flow down here. You know, when it reaches a branch here, and any answer, any decision that the program made will be here. So if it is 2, it will come to even. If it is 2.5, 1.5, 3.5, anything 2.7, so far there is remainder. That's why we said remainder. That's why I put question mark here. Is that remainder? If there is remainder, to move here. If there is no remainder, it will move here. And if there is no remainder, the answer will show output answer. This will be answer equal to even. And if there is remainder, answer will be odd number. So I think that's it for today.